All right, welcome. Captain Coder here, getting ready for a game jam, doing Trijam number 149. So if you're new to Trijams, the Trijam I'm doing, or the game jam I'm doing, is a 3-hour game jam. So the challenge is to create a game in 3 hours. All right, so that sounds impossible. This will be my fourth one. We'll see if I can get it done this time. With the exception of my first try jam, I've gone over every time. So my first try jam, I managed to get it in under 3 hours. The second one was like a 5. Um, try jam 148 was 3 hours, 25 minutes. So it's tough. It's tough to get it in there. It's tough to get it done, but leveling up my Unity and C# skills, which I'm not the greatest at. I think I'm a pretty good programmer, but my Unity and C# skills need a lot of work. So I am going to keep doing game jams. Next 2 weeks, I'm going to be doing Board Pixels jams number 9. So I won't be doing try jams, I don't think. But this weekend, we're doing the try jam. The theme is Flip. And so I'm pretty excited about this one. There's a game called Flip Legends, which I think is awesome. And so I'm going to see if I can create a game that is similar to that. So if you're not familiar with Flip Legends, it's a game in which you play characters that flip around on the screen, defeat enemies, you die. It's like a speed game. You have like a timer, and you can collect things that increase the amount of time you have. But you got to be fast, and then there's like spikes and obstacles on the screen that can kill you. So yeah, I'm gonna see if I can do a game similar to Flip Legends. And so one of the things with Trijam is trying to make sure you plan enough to be able to complete your game in 3 hours. If you just sit down and start writing code, you are definitely not going to finish in 3 hours. So I'm getting better at doing time estimation. So let's start off by going to my doc cam here and doing a little bit of planning. I have a general idea, but let's do some planning to get ourselves in the mindset of what we're going to try and accomplish in our first session. So usually I try to have a complete game in 2 hours, and I try to do 3 1-hour sessions. This time I think I'm going to try and do 2 sessions, a about 2-hour session, and then a second session for cleaning up. So I always try and want to have like an hour left at the end just to put some polish on. So in my mind, I got to make the game in 2 hours. All right, for me, I'm going to do the programming in 2 hours, and everything else, all of the art assets, audio assets, I'm not going to make those. Or if I end up making them, I'm not going to count those against my time. So let's start out here. So we got Trijam 149 Flip. Okay, so the things that I'm going to need for this, I'm going to need to keep track of a grid like this. And so the grid just sort of is going to extend forever or a specific amount. The player is going to start down at the bottom. We got our player here. And I'm going to try and do a 3D game here. So we're going to have a camera back here that hovers above the player, and as the player moves, the camera follows him. The ambiguous character, and then there can be spikes, enemies, and coins. So I have some spikes that I'm going to use. I got a skeleton asset I'm going to use, and I got a coin asset I'm going to use to collect coins. And so the player, there's 2 keys you can press. You can press left, you can press right, and it's going to move you forward and left, or forward and right. If you jump off the end, it's going to move you all the way to the leftmost spot. And if you move off the left, it's going to move you all the way to the rightmost spot. if I have time, and I think I'm gonna go ahead and add this in, there's also gonna be a back button, which allows you to go back one space, but you can't use that all the time. So that is like an ability that is like on a cooldown, or maybe you can only use it once every couple of jumps, but you can't always use it. So the idea is you have to be able to get all the way to the end in a certain amount of time. So the way I'm gonna do it is you're gonna have a start, gonna be a finish, and when you get to the finish, that's gonna be the end of the level, and it's gonna tell you like how much time it took you to finish it, time plus score, something along those lines. If you die, it's gonna tell you how far you got. When you start over and you get to the end, it tells you time, score, and then it's gonna generate more for you to go. So the game is just gonna be like infinite, but there's gonna be a certain amount of time necessary to get from the start to the end, and then it'll pause there. Give yourself a breather, and then make it so you have to keep going. All right, so what am I gonna need in the code? All right, so this is a flipping game. So I have like a character model here. So I have two character models. I have one with a character standing upright, and then I got another one with a character. It's actually same character, standing upright, but with their arms up. So I'm gonna have to animate in the game. When I move forward, the character animates that spot and flips. All right, so the character is gonna flip. So player controller is gonna be the script that I use. All right, and so I'm gonna have a couple movement or inputs. So I have left, right, and down movement. So let's go left, right, and back flip. So user input. I'm gonna have to, for the player controller, I'm gonna have an animate move. All right, so it's gonna move the player to the correct location. I'm gonna have an animate jump. All right, so this is gonna make the character move up and down between those two things. I'm gonna have to have an animate flip. All right, so that's gonna keep track of the flip, and then I'm also gonna have to have an animate model switch. Okay, so the flip is just gonna rotate the currently visible model, and then I need to actually switch to the arms we know. So the character halfway through the jump will actually swap into the other model. All right, so that's the thought process right now. So I got my player controller animate move. I'm gonna have to have a handle input method. So this is gonna, when you press it, it's gonna set player's position. So it's gonna set the position sort of in the game. All right, so that's my player there. I'm gonna need some colliders and stuff, I think, to detect. I might not use colliders. I think I'm gonna actually have, yeah, I'm not using colliders on this. Everything is gonna be not hard coded, but coded. The game board's really just two-dimensional, so it's gonna be coded in there. So if the players hit something, it's gonna be part of the grid rather than part of a collision. Otherwise, based on the way I'm thinking about doing the game, you could move really fast and like not actually collide with something. All right, so my player controller to move stuff. Then I'm gonna have to have a grid controller. So I'm gonna have to have a thing that sort of generates my grid out into the world. All right, so I'm gonna need a generate method. So the generate method is gonna just draw my grid out there. Inside of my grid controller, I need to have like tiles. So I'm gonna have a list of tiles that it can draw, and it's just gonna be the floor. I'm gonna have a list of obstacles that can be drawn, a list of enemies that can be drawn, and a list of like power-ups. All right, so I have a list of these things, And so the way the generate's going to work is it's just going to start in the bottom left and boom, draw tiles. And every tile, there's going to be a % chance to draw an obstacle. And if the obstacle doesn't get drawn, there's a % chance to draw an enemy. And if an enemy doesn't get drawn, there's a % chance for a power-up to be dropped. And so we're going to start out with 1 obstacle, 1 spikes, I have a skeleton model I'm going to use, 1 skeleton, and 1 coin. And if things go well, we can add in some bonus stuff there to make the game more interesting. So I'm going to need my tile generator. I'm going to have to add enemies, obstacles, power-ups. All right. And then I'm also going to have to keep track. So I'm going to have a grid in here. So this 2-dimensional grid that keeps track of what's in the space. So it's going to be a grid of obstacles, a grid of enemies. So I'm just going the easy route, a grid of obstacles, enemies, and a grid of power-ups. So I know when my player moves into a spot, I can say, okay, is there an obstacle here? Is there an enemy here? Is there a power-up here? If so, do the appropriate thing. All right, so that's my grid controller. It's going to keep track of all of those things. I think that's about it as far as what I want to get done initially. Let's have this grid controller out there, have my player movement. All right, so in this first session, what do I want to do? First thing I'm going to do, create grid/grid controller. So make something where I can generate my grid out in the world. Okay. 2, create player/player controller. So I'm going to then create a player, put it out on the world, and make it so I can move around in the environment. All right. 3, create obstacles. All right, so add spikes. Okay, after I add my spike, I'm gonna update grid controller to generate my spikes out in the world. 4, create enemy, same thing. 5, create coin. All right, so those are the first things that I need to do. If I have this done, I have a playable game. I have something that does a thing. Okay, so in my first session, this is what I want to get done. And then I'm going to come back to planning, see what I want to do next. All right, so I am going to switch to my face cam so you can watch the horror on my face as time slowly ticks away. Here we go. Face cam. Okay. So, yeah, that's the plan. I have Unity. I've preloaded Unity. I have my VS Code. Let me have a repository. All of my source code's available in my GitHub repository. I'll add a link to it in the description at some point. But initialize project. So initialize my project here. Oops, forgot to actually add stuff. Let's commit, sync that. All right, so I got my VS Code open. I wrote a little test script just to make sure. Sometimes VS Code doesn't talk with Unity, so I wrote a little test script just to make sure my stuff was working. I can actually delete that now. So I'm gonna go ahead and delete the test script here. Okay. It's rebuilding. You can't always see. So I have the way my broadcast is set up. You can't see like the extra windows and stuff that pop up. So I apologize for that. Okay. So I have my empty scene here. I'm gonna load in my assets and then I'm gonna start my timer. All right. So my assets. pulling those up real quick. Give me a moment. Navigate to them on my computer here. Okay. All right, so dragging in my assets, import. Okay, so there's a bunch of assets that I went and found found some voxel art, converted them to OBJs, and these are all the assets I want to use with my game. So I don't want to count that as my time, but I am ready to go here. So I'm starting my timer in 3, 2, 1. Let's jam. Okay, so I have this skybox material. I'm gonna go ahead and make my sky this material. Okay, and then I'm gonna start making my grid. So I'm gonna create an empty container here called grid. Let's put it at the center of the world. Let's create an empty container inside of it, tile container. And this is gonna be what we use to hold tiles. All right, so we got some tiles here. Tiles are just gonna alternate between these light green and dark green. And so I gotta make my tile container fill up with those. Okay, so let's create a grid controller. Grid controller, make a new script. Did I hit? I guess I didn't hit that. New script, grid controller. Here we go. Create a new folder to hold all my scripts. Create folder scripts. Grid controller goes in there. All right. Let's go ahead and open that up. Okay, so my grid controller, I need a couple things to make this work. So on my list here, I am going to have, first I'm going to need everything to be able to sort of access this. I'm going to create a static instance of my grid controller, and when the game boots up, that's going to just get set equal to this. All right, then I want a width. So this is the width of my grid, and then this is going to be the distance of my grid, how many tiles out into the world get drawn. And then I need a reference to my transform. This is going to be the container that is going to hold all of my game objects. All right. So next I want to, I need a reference to the tiles I'm going to generate. So public game object tiles. So these are the different tiles that I'm going to alternate through. I'm going to go ahead and connect everything up here on my grid. So here's my container. Tiles. I have 2 tiles that I'm going to use. If I go to my tiles, all right, so tile 1, tile 2, pop those in there. I'm gonna have a width of 3, and let's just go with a distance of 100. Start out, and let's get a generate grid method written, so that way we can have a grid drawn to the screen. So this, we need to start out by destroying anything that's currently in our container. And so I'm actually just going to copy, I have some code here that I've written in the past for doing Unity utils. So I'm just going to add that in here. Create new folder, Unity utils. Move that into my assets. And then create a new file, Unity utils. And let me go find that file real quick. Get that on my clipboard. And then we'll just dump this in here. All right, so this is a little script that I wrote so that way I don't have to think through the process of removing all of the elements inside of a component. So I want to delete everything inside of this transform. And inside of the container. So I'm going to delete all the previous tiles, and then I'm going to rebuild them. So I have a little utility I've written. I gotta click over to Unity real quick to get it to rebuild to find it. And then I can do captain, coder.unity.unityEngineUtils.instance. I should probably, it's easier to destroy children on this container. Okay, so that's gonna empty out that container. And then I'm gonna do a nested for loop where I loop through all of the columns and rows that I need to draw, that I need to generate onto the screen. So I have this nested for loop. It's going to go through 0, 1, 2, 0, 1, 2, 0, 1, 2, and the row is going to keep increasing all the way down to the end. All right, and so then I need to get the tile that I want to do. So I'm just going to alternate the tile every time. So I'm going to sum my row and my column, and then divide that. So this is the remainder of, if we were to divide the row plus column divided by the length, we get a remainder. So it's always going to be 0, 1, or 0 or 1, 0 or 1. So it'll keep alternating. And if I add more tiles, it would just keep swapping between all of those. So game object tile equals unity engine.object.instantiate. So I'm going to instantiate one of my tiles, and the tile I'm going to do happens to be the one that I defined there with my index. Close that so we can see this a little better. Okay, so I have the tile I want. Then I got to set the parent of that tile to be my container. And then I'm gonna update its local position, so the position inside of that container, to basically be the column and row. And I think this is right. Z-axis is depth usually, so that's gonna, the row is gonna go out and my column's gonna go. I think I got it. And then just so I can maybe debug it later, I'm gonna give it a name, telling me which row and column it is at. Okay, I think that should do it. Let's pop back over to Unity. We're gonna click play and hope it generates those things. When I start the game, I'm gonna actually call generate grid. Okay, so pop back over, call generate grid on start, and then I'm gonna click play, and there we go. We got a nice grid running out into our universe. The camera's bad, but we'll get that fixed. Ooh, I'm gonna have to write a camera thing to follow where the player object is, but that shouldn't be too difficult. Next thing I want to do is I want to make it, this is a little annoying that it doesn't generate till the game starts, so I'm going to actually add a little component here so that way I can just call generate inside of my editor. So grid controller, nope, that's not what I wanted. I'm going to create a new script, grid controller editor. Controller manager, I'm not sure. I need to give it come up with better naming scheme, but just created a new script. So I'm gonna move that into my scripts folder, and then I'm gonna come over here and open that up. And so this is gonna be a special object that just allows me to call the generate script. So it's going to have one thing, and it's just going to have a grid controller, and then I'm going to write a custom little editor menu for it real quick, so I can click the click a button that will generate. All right, so I just added that in there. I'm going to need to import using Unity editor. And then I need to add this little tag here. This makes it so I'm adding some editor components here. So if I don't add that in, it won't let me build my game. Controller manager. Okay, public class. Grid editor. Okay. So custom editor. And then there's a method, public override, void on inspect. There it is. I've started doing this enough times that I can sort of GUI.begin check like this. And that I kind of, so this is going to make it so I know how to save. If there are changes that were made, then I need to do editor scene. Editor scene manager. And where do I import this from? Editor scene manager. Unity editor scene manager. Okay. Mark scene dirty. Editor scene manager get active scene. Okay. So this code is going to check to see if anything changed, and if it did, it makes it so that our Unity editor will know and be able to tell us that we need to save the changes. Next, grid, what did I call this? Grid controller manager. Manager, it's equal to grid controller manager target. So there's a special protected variable inside of an editor of what you're working on. And then manager dot controller equals grid controller. Oh no, this is the controller, so this should be a grid controller. And we're going to create a little editor for it. Editor GUI layout object field. And the object is the manager dot controller. Type of grid controller, and I think we need to put true to make it so we can drag it from the scene in there. Click over here just to make sure this is the case. Yes, multi-object editing not supported, that's fine. And then I want to make it have a button. We're going to add a button called generate grid. And this button is going to call the generate grid method on our currently selected controller. Okay. And there's no button. There's no button. What did I do wrong here? GUI layout, generate grid. Grid controller manager. Oh, there it is. I'm just dumb. I can't see it. It's right there in my face. All right, so my generate grid will now, boom, calls that method in my world. And now I can see what it's going to look like and sort of position my camera and stuff appropriately. Okay, so I got my grid in. We're 13 minutes in, making progress. All right, so next, I'm going to create an empty object for my player. And I'm just going to go ahead and add a player controller script to my player. All right, so generate that script so that way I have it. Put it in my scripts. All right, next I need to go ahead and I'm going to add in here. I have my Ninja prefab. All right, here's my player model. Drop that in there, and let's position this column 1, row 0. So, not quite what we want. How high do I need to make this to? Ooh, that's right. So I'm gonna have to be switching between these. So Ninja hands up and Ninja hands up. These are named poorly. All right, there's our fella. And so the height should be 0.2. Gotta zoom in here. 0.25 looks about right. All right, so there's our character model. All right, and so the idea now is that I can rotate when I move. I can rotate by 180, and then I just switch these models, and he's doing a handstand there. All right, so that's the plan. That's the plan. Let me get my, unrotate this. All right, so now I need to go ahead and work on my player controller, make it so when I move, the row and position of my player gets updated. So let's open up player controller. All right, so we got player controller. Looking at my list here, get my user inputs. So I actually need to define my user inputs. You won't be able to see this because Unity or OBS won't show this, but I'm going into my project settings. I'm updating my input manager to have the inputs that I talked about. So a left, a right, a back, and then I actually will add a special none option for when I end up with a UI. I want the none option to be available for me. So I got left, and my positive buttons are A and the left arrow, and then I got right, and my positive buttons are D and right arrow. And then I'm gonna just call my next one down. I've called it other things in the past and I just always confuse myself. So S and down. Down typo. My last one I'm just gonna call none. Okay, and I know you can't see that, but you just gotta trust me on it. Okay, so now I'm gonna write a quick method for my player here called move. And this is gonna take in the number of rows and columns that I want to move, and then it's just going to sort of wrap itself and force itself onto our grid. Okay, so this dot. Oh, I need to add some methods or some fields here. So we have a public float, row call, last row, last call. Last row and last call are going to be useful for doing doing animations so that we can sort of do a linear interpolation and make sure that they show up in the correct locations. All right, so now down here, this dot last row is equal to where we were. This dot last call is equal to where we were. And then rows, just increments by rows. And then calls, column, we got to do something special here. So we are going to add this together, and then we got to, we want to find the remainder. So we need to divide, but this can be negative if we end up jumping off the left side of the board. So we have to do a little bit of something special here. So I'm gonna actually create a width variable, grid controller dot instance dot width, because what did I call it? Grid controller width instantiated the wrong thing. Instance dot width. All right, so I'm gonna get my width just so that I don't have to type that whole thing out a bunch. There's a little hack I'm gonna do here, where I'm gonna make sure. Oh, I gotta do mod width. So sometimes this will give us a weird negative number, and then I need to add our width. Don't worry too much about this. Just trust me on this one. It's a weird little hack that you have to learn when you're doing modulus arithmetic. So we're gonna find it, and we're gonna find the correct position. All right, so this is gonna update our row and column to the right spot. I need to keep track of when the movement was made. So I'm gonna do a moved at variable here. And this is going to track when the player moved at. So this is going to be equal to time.time. So this will be useful later for doing animations. Moved at, and then I also want to have a float that move duration to keep track of how far we're gonna move. Okay. Then in my update, I need to actually perform the move. All right, so this is where I actually need to do a handle input. I need to actually read the user input first before anything else. So if, oops, can't just write that there. Public void handle input. I'm gonna go ahead and create a handle input method. This is gonna handle all of our user input. And in our update, it's just gonna keep checking that. So we have an if our user input get button down, so when they press the button left, so if they press left, we're gonna this dot move left, we're gonna go forward one and to the left. Is that right, rows? Yeah, forward one and to the left. All right, if the player presses right, this dot move, we're gonna forward one and then to the right. Okay, and then if they press this while I'm here, button down, what do they call it? I think I'll down. I'm gonna go ahead and add a boolean called can backflip because I know I'm gonna need this later. Public bool can backflip. All right, so backflip here. If by default, we're just gonna set this to true. All right, so if we can backflip, we're gonna go ahead and move backwards. This dot move -1 0. Okay, so now we get our rows and our columns updating. Let's just check this out real quick. The actual model isn't gonna move yet because I haven't written that, but I wanna make sure I have my movement correct on my player. If I click on my player, I can actually watch it here. Yeah, okay. So I can watch, if I'm just pressing right, 0 1 2 0 1 2. Okay, all right, I got my math right there. Okay, so I have my input done. Now I need to get my animation. So I need to animate the move, which I think is going to be some of the harder part of this code. So public void animate move, and so we're going to do an animate move every update. And in this code, we need to figure out where we should position the player. So we need to calculate sort of so let me think about this real quick. So we got to have, I'm gonna create a variable that tells us when the movement should be done. So this is moved at plus move duration. These were the things that we wanted to have. All right, so, and then we're gonna say if the current time, if the end movement, essentially if the current time, if we haven't reached the end of the movement, we need to calculate where we're gonna go. So create a percentage here, which is the current time minus when we started divided by the move duration. Okay, so this is gonna give us the moved at's gonna always be something that's less than time. It's gonna start, it's always gonna start at the exact amount of time. So when we first move, this will be 0, and it's just gonna increase. And it'll be 1 when the amount of time that has passed is equal to the move duration. Okay, so then we can calculate, let's see, we can calculate it. Our start position should be equal to our last row and column. So we're gonna create a new vector 3, last column. We probably need to put floor height, create a variable in a second, last row. So floor height's gonna just be a constant. We are gonna be jumping up and down. So I think Actually, I'm just going to copy this from our last. I think this will be okay. So I'm going to do transform.position.y. So we're not going to change our up and down. Vector 3 and position is equal to a new vector 3. It's going to be our current column, transform.position.y, and our current row. Okay, and then we're just going to Unity gives us a bunch of tools. We're just going to utilize them. So vector 3 new position is going to be equal to vector 3 dot lurk, which we can give it a start and end position, and then the percentage where we want to do, and it's going to find the spot right inside there. And then we want to just this dot transform dot position is equal to new position. If we're already at the end of the time, I'm going to move this out here. I'm going to actually define this variable here, set it here, and then by default, it's just going to be our end position, actually. So restructure my code a little bit here. Okay, so this is, I think this is correct. We're going to find out. All right, so I'm going to come back over to Unity, see if I got my code right. I've written this type of code. So, all right, so we can see my player jumping around over there. Let me write a script that will follow my player around the camera. So I'm going to go to my camera, and we're going to do a camera follower. I'm going to create a script that's called camera follower. I'm not very creative with that name, but don't need to be. Okay, so my camera follower, it just needs to know what it's following and how far away it needs to be. So public transform target, public float distance. Okay, and all right, so then it should just update to be target. Okay, this dot transform dot position is equal to target. Oh, well, we just want the new z. Okay, so I'm going to create float new x equals transform dot position dot x, float new y position dot y, float new z is equal to target dot position dot z minus distance. All right, so that's how far. And then we're just going to say this dot transform dot position is equal to new vector 3, new x, new y, new z. All right, so the camera should follow us now. I just got to get it centered on the player first. So I'm going to update that, start out at -2, and then move it over 1. All right, let's test it. I didn't set who it's supposed to be following. It's going to follow the player model, I think. Okay, and then because I don't think the player, doesn't matter if the player's there and then the distance was 2. I think that's what we have there. Okay. All right, so now we follow the player. All right, and I need to make it, I'm gonna make it so the camera will follow at a speed. So public float speed, 3. Let's try 3. And so it's gonna say if this dot transform dot position dot z is less than new z, we're just gonna move forward. Otherwise, yeah, here we go. If it's less than new z, Our current position is less than new z. New z is equal to this dot transform dot position dot z plus speed times time dot delta time. I think that's what we're gonna do. So we're gonna move towards that spot as long as our this dot transform is less than. Otherwise, well, let's see. We'll see. I think I kind of got it right here. So we should like smoothly follow. There we go. All right. And we can get pretty far ahead of the camera. We'll keep moving. So I'm going to add a little thing to make it so that the speed of the camera will increase. It'll get like a bonus speed if it's further away from the player. The further away it is, the faster it'll move, and it'll like slow down. Okay, so we're gonna do based on the distance here. Float bonus is equal to new z divided by 2. All right, so speed times speed plus bonus. All right, this should make it so the camera will move faster based on how far away it is. Yeah, so now if I move super fast, the camera will always catch up. Oh, it wasn't. I want it to not. The new z. Oh, I want to get the actual distance from it. Okay, so I need to actually do float d for distance is going to be right. Yeah, we want to figure out how far away we actually are. So our target position dot z minus our current position. Okay, so I'm gonna get my current. Yeah, like that. So rather than doing it, there we go. It's just gonna be getting faster and faster as long as the further along we went. All right, so now the camera should. Am I doing something wrong here? Camera, it does get faster, just the ratio's not fast enough. We'll just have our bonus be D probably. Let's see if that is good. We're 31 minutes in, so I'm feeling like I probably should just move on here. I want to make the game feel nice. Okay, that's all right. Oh, let me just maybe slow the speed down a little bit, the default speed. There we go. Oh yeah, that looks good. Okay, I'm gonna set our speed to 2. Okay, got our player in there. Let's adjust our player speed to see if my animation stuff was working. Move duration, let's try 0.33. So. All right, now it'll actually move between the spots, and we can, if we're tapping really fast, it'll jump between the spots, but I'm okay with that. Okay, so the movement's pretty, I like it. Camera follows at a reasonable speed. We can get ahead of the camera if you're moving you're tapping it really fast, but camera will get a little bonus. Okay, 32 minutes in. Let's keep going. Back to my player controller. I got my animate move. Let's do an animate jump now. I gotta get it to jump up and down. Okay, public void animate jump. Okay. This is gonna be very similar, but I need to calculate the midpoint. So I'm gonna use this sort of as a template. This is usually bad to copy and paste like that, but we're prototyping midpoint at move at plus move duration divided by 2. So it's our midpoint. End position. We might not need this here because our end position is going to be like something different. Yeah, so that's right. new. Yeah, our height will always go back to 0. So we're actually going to be moving our player object up and down. So I need to get a reference to that player object. Public game object player model. All right, so I'm not moving my player. I'm going to move my player model up and down because that way its Y position doesn't have to change. Let's go to our player. Oh, I got compilation errors. Let's just comment that out for a second. So don't forget to attach it. This is the biggest thing I do. All right, so we're going to attach our player model here. Okay, and if our midpoint is greater than our time, we're going to be jumping. All right. Else, if our end move is greater than the time, then we're going to be falling. All right. So going up, going down, and then if we're at the bottom, we're just going to be set to 0, 0, 0. Okay. So our start position. This is actually going to be, our start position should just be new position, actually. So we're starting at 0, 0, 0. And our end position is going to be 0, 0. And then we need a jump height. So I'm going to create a variable called jump height. Public float jump height. Got someone in the comments saying limit max speed of the player. So the idea with this game is there's going to be a timer, and so you're going to want to be able to go as fast as possible. There's going to be a timer that you have to block, jump, get past obstacles, and if you miss, you want to be able to move super fast. So that way, yeah, I'm not going to limit the speed of the player. If anything, I need to just adjust the animation speed and stuff to do something smart. But I don't want to limit the speed of the player because you want to be able to move as fast as possible. Okay. Where was I? Jump height. Yeah. Okay. So my new position, blur between my start and percent. So this is when we're going up, and then here, this should be divided by time. Move duration divided by 2, so it's our midpoint. And same thing here. This one should be time minus our midpoint. Move duration divided by 2. And then we swap these. Our end position is new position, and our start position is up high. Think this worked. Let's test it. Hop back over here. I gotta set my jump height. Let's try 1. Oh no! All right, jump height 1. Start position, end position. We're going between those two. Our new position. And up here. This is probably just because I'm saying this equal new. Let's do new vector 3. Let's try this. Maybe some sort of reference issue. Looking at my code here just to make sure. Oh, this needs to be this dot player model dot transform dot local position. Okay, so I bet this was doing something. It just was moving our player thing up and down, and our model wasn't moving at all. Oh, come on. What am I doing wrong here? Okay. Midpoint. Time. Alright, let's get this to go up. end move at our move duration, our midpoint at moved at plus divided by 2. And then this is where we're going to end up. And then our percent, our time minus how much we moved, or when we moved at, divided by this. That should be correct. Oh, I never caught animate jump. Ugh, silly me. Okay, here we go. Let's try now. There we go. Okay. Now we can get jumping. All right. Okay. Okay. Now I want to get, so I got move, jump. I need to get the flip in. So I'm going to do an animate flip so I don't forget this time. Okay. Bring it down here. Public void animate flip. Okay. So flipping is a little bit different because we're modifying the rotation. And rotation is a little bit tricky because it resets when you get to 360. 360 and 0 are the same. So you got to be, there's a little bit of trickiness in Unity to make it work right. So, but we're following the same formula. And float and move at plus move duration. So we get the total amount of time we need to do it. Then our end angle is going to be based off of the row we're in times 180. So every row we're flipping 180 degrees. And following the same, and I'm actually just looking up here, following the same sort of formula, end angle. If end move at greater than time.time, then we're going to do something. Otherwise, we're eventually going to update our player models Euler angles so that we can specify these in angles and not in Euler angles rather than using like radians. I think otherwise we'd have to do some math to do radians. Float percent still this here. Probably could have typed it out just as fast as doing that. That's okay. Float start angle is equal to the last row times 180. So the previous row, we're gonna get that. And then our new angle, we're gonna use lerp angle to calculate our angle. Start angle, end angle, percent. Okay, so this should make our model flip, and it's gonna do weird stuff. So the head's gonna end up in the ground. All right. Okay, so now we got that going on. Okay, and then the next thing I want to do is make it so that we switch models and switch check switch model. Okay, so we're going to switch between the character model. So I'm going to need a reference to those. Public game object, and we're just going to have an array of them and use modulus on it. Models. I'm just, the name player model and models, my brain was struggling to decide what I should do, how to comprehend this. Public void switch, what do I call it? Switch check switch model. Public void check switch model. Okay, let's go ahead and connect that up here so I don't forget. And so I got my player object and my models are these. I want to add these into here. These are the models. Added the wrong thing. There we go. So we're going to switch between those. I think they're in the order that we want, but we'll find out in a moment. Check switch model. We need a switch at the halfway point, so I'm going to be doing something like this. So I'm going to just copy this again. Clear it out of here. I don't need that. I need the midpoint. I need to figure out at the midpoint's when I'm going to switch. All right, so game object new model is equal to player. What did I call it? Models. Terrible name. Row mod models dot linked. So I'm just going to keep alternating between them. It doesn't like that. You're not imposing for float to int. Row is a float. Oh, these should be int. It's a discrete grid. Okay. Might have just blown everything up, but we'll see. And then if I'm at the midpoint, if I'm not at the midpoint yet, my model should be the previous spot. So new model should be models, row, last row, models.link. So I'm gonna get the previous model if I'm not the midpoint. Then I don't need this else if here because I'm not actually doing an animation. I'm just gonna swap it. For each, I'm gonna just loop through these. There's probably a better way to do this. In models, I'm just gonna go through and check if my new model is this one. This will let me put like additional models in there if I need to. Set active true, and otherwise obj.set active false. Okay, and then finally, I don't need to do anything with that. Make sure I'm calling it. Check switch model. Okay. All right. Let's check it out. Yeah. That came out pretty cool. Let's slow it down so we can watch. Okay. That's I'm pretty excited with that. Okay, so I got my player movement done. Player is able to hop around the screen. Let's add in some enemies to our grid. All right, so in our grid controller, we're at 47 minutes. Grid controller. I need to have public game object obstacles. Okay, so I got some obstacles, and so I'm gonna go ahead and add in my spikes to this. Let's uncheck that. Go to my grid here. Lock my grid in. Obstacles, spikes. Add in my spikes here, and now I need to randomly place spikes. Okay, so every time we make a tile, we're gonna randomly check. I think I want to use system.random because I want random.seed. What should I use instead of? All right, I'm gonna use system.random because I want to be able to using. Oh, shouldn't do that. That'll be an issue. Yeah, my grid. I want my game to be repeatable, so level 1 will always be the same. It's a randomly generated level. Maybe. All right. I'm talking too much. Let's just do it. Public system.random RNG at start. RNG is equal to new system dot random, and we'll give it seed 42. So it should always generate the same maps at the start of the game now. And so that will... Ooh, I have a better idea. No, that's going to make me have to change too much. Oh, this is... I have a little check here. If... here... New system. Friend. We're just going to do this for now. Okay. If RNG dot next double, this should return a number between 0 and 1, is greater than 0.8, so 20% of the time we'll just create a spike at that spot. So we're gonna do I'm gonna write a thing, public void generate obstacle, and give it int row int call. Okay, and it's gonna look essentially like this. Okay, rather than tiles, this becomes obstacles, and this becomes obstacles like that format. And so if we're greater than 0.8, then we're going to generate obstacle at row call. Okay, let's see what that looks like. Loading. Did generate some spikes. I can also click here. Ooh, that looks like way too many. Next up, double. Let's make it so it only shows up 10% of the time. Seems like they're showing up very frequently. Also, they're showing up. I need to adjust this prefab so that the oh, that's not a prefab. That's what's going on. So here we go. I'm gonna make it this. Right, let's just delete both of these and re-add this prefabricated one. Okay. Generate. There we go. Those spikes look good. I don't like how frequently they're showing up. Next double. Let's do 95. Or my brain will work better if it's less than 5%. So it's saying 5% of the time they should show up. There we go. Probably have to do something to make sure that it's possible. Alright, so we're gonna make it so if the player lands on one of those, they'll die. So you can't land on any of the spikes. Alright. Oh yeah, I forgot we could backflip. We gotta make sure that it's possible to get through everything, so. Alright, that's pretty good. I like it. Let's see here. What do I gotta do next? So I got that in. Let me add in enemies and power-ups. Alright, so essentially the same thing here. Obstacles, enemies, power-ups. Enemies, power-ups. Okay, and doing the same things. We got skeleton. Is this the prefab? It is. Alright, so enemy, add that in, and then come down to pirate coin. That's right. Alright, and that's going to be our quote-unquote power-up. Okay, and do something similar here. Generate obstacle, generate enemy. And if I wasn't in a rush, I'd spend a little bit of thought about, since these are all essentially the same code, I should probably abstract it, but but I'm not going to worry about that. Because I mean, this is essentially making it, if I need to change these, I'm going to have to change it all over the place. Which isn't ideal. Power up. Because I noticed the pattern here is just boom, switch that, switch enemy, switch the list and the text. That's all I would have to do. That's what I should do. I was, oh, and then I want to. All right, if we didn't generate a enemy, then we might, if we didn't generate an obstacle, we might generate enemy. And if we didn't generate either, then we'll try to generate power up. Okay. And why? Oh, I gotta give it the row and call. Row, call. Okay. And I'll play around with those values. I should probably put them as part of my controller here. Yeah, so let's do that. Let's put obstacle chance, enemy chance, and power up chance. Okay. And we'll just do public float, enemy chance, obstacle chance, power up chance. Save. Set those over here. Our grid. So obstacle chance was 0.05, power up chance was 0.10, and enemy chance was 0.10, power up chance, let's go with 15. All right, generate grid. There we go. Seems maybe a little excessive. We should probably limit it so we can't get too many. All right, got a nice little sink getting built here though that we can hop through. Our skeletons are facing the wrong way, but let's go ahead and I'm gonna update. I'm gonna write a little script so that the skeletons will always face the player. That should be relatively easy to do. Open up my skeleton prefab here. And we'll add a component to them that is called iFollower. I'm gonna write a little script where in our update it will always look at the player. So we're gonna have a public transform target. Okay. And then when we go to update, in my player controller, I'm going to get a reference since these are prefabs. Let's make a instance public static player controller instance like this. On when we boot up, instance is equal to this, so that we have instantiate instance. iFollower, if target is null, we're gonna set target equal to player controller.instance. Else, if we already have the target, we're gonna go ahead and change the way we're looking. So vector3 look position is gonna be target dot position minus the position of the skeleton. I might need to flip those two values, but I think that's right. Look. And we don't want it to like rotate up and down, so we're gonna set the Y position to 0. And we're dealing with quaternion, so look, rotation, we're gonna tell it to rotate towards this. Player controller.instance.transform. Okay. I think that should get our skeletons looking at the player. Yeah, look at that. They rotate towards us. I like it. Woo. Okay, let's 59 minutes. Let's add a script to make our coin rotate. Let's get a little nice thing in there. So our coin prefab was here, and I'm just gonna add on to this pirate coin that I want. Hang on, let me go to my scene. I think I need to rotate on Y, but I might. Sometimes I'm really dumb. So select this coin if I rotate on Y. Okay, yeah. Okay. I'm gonna rotate on Y. So go to my coin. I'm gonna add a component called rotation controller. Move it to my scripts folder. And this is just a little nice thing to do when we update. Let's do float speed, upload float speed. Let's try 15. And we're just gonna rotate. All we gotta do is rotate this object. This dot transform dot rotate speed times time dot delta time, and we're gonna do it in the world speed. Oh, this needs to, we're rotating, so this needs to be a vector, I think. Public vector 3, new vector is 0. All right, let's try that. Let's see what that looks like back here. That's pretty slow. Let's try 90. I think that's gonna be, I think this is in like seconds, so it should do 90 degrees a second. So maybe I want to do, and it's on the prefab now. I'm gonna actually update it here. Pirate coin. All of these are going on here. Grid. Great. Yeah, so I need to, I think maybe just re-update to, that's like an old. All right, let's just drop the pirate coin out. All right, and I think that'll do it. Why are they so slow? Pirate coin prefab Y is rotating on 90. But my power up rotation is set to 15. That is really annoying. Generate grid, power up. All right, let me try getting rid of. Gonna crash. I don't know why that's doing that. I'm just gonna get rid of that, make it 90 in the code because I can't spend time figuring out what's going on. All right. 90. I want 180. I want it twice that speed. So every second it will flip once. There we go. All right. All right, I'm at an hour. I'm stopping my timer. I'm at an hour and 3 minutes. Pretty happy with that. Hour and 3. Can we get on there? Hour and 3 minutes. And I have the base game added. So I have my player movement. I've got it generating kind of. And so I have something that's semi playable. I don't want to call this a game just yet. Something where you can do a thing. Okay. I'm pretty happy with that. In an hour and 3 minutes, so pretty excited. So I'm gonna take a break, and I'll probably be back in the next 30 minutes or so. I'm gonna take a break, think about what I want to do in my next session, and if you're around in about 30 minutes to an hour, come on back, and I will be adding in my next step. I believe I'm going to be adding in the actual gameplay elements. You can collect the coins, destroy the skeletons, die, and when you get to the end, it needs to tell you your time that you finished, and have you sort of like spawn at a start or generate, have the grid grow to the next quote-unquote level. All right, thanks for watching. I'll see you next time.